Okay friends, today we are going to solve another problem for cycloid. So the statement is draw a cycloid for a circle of a diameter 35 mm. So we have to draw a cycloid for circle having a diameter 35, and the circle is rolling along a straight line without slipping. So that circle 35 mm is actually rolls along a straight line without slipping. Take the initial position of point P at the contact of circle and straight line. So first of all we will see the concept. Suppose this edge of a scale is a straight line, and there is one circle. This circle suppose having a size diameter 35. Initially it is resting on this point. Suppose this is point 1, or suppose it is initial point where the P point is located. So at this point P is located. When it is roll one division and this one point touches the road, that is a straight line, so P point will lift it little bit. When it roll and reach to second point touching on the road, this is second point, then P point lifted again. When it roll and reach to third point, when third point touching on the road, then P is again lifted. 4, then 5. So like this the disc or circle is rolling, and the initial P point which is given at the contact, its P point location is varying. This is 6. When it reach to 7 point, so P point will be here, and when it complete one circle rotation, so it will cover exact circumferential distance and reach to 8. That means again P point will be at contact of line and circle. So we come to know that when circle roll without slipping, means it is not slip like this. So it is continuously rolling on the straight line. So when it is rolling, initially P is here. When one division rolls, P is lifted. Not only lifted, but it travel, because circle is also moving forward. So P is lifted, and it travel in the direction of rolling like this. The second important point about the center of this rotation. This center of rotation is from this to this, it is about a radius distance. When it roll one division, still center is at height wise same radial distance. When it reach to second position, height wise same radial distance, but linearly initially center is here. When it roll one division, height wise same height acquiring by the center, but linearly it is shifted to this. When it rolled 2, height wise same distance but linearly shifted to this location. So center is linearly moving forward as the division of rotation completes, but height wise it always remain at the same level. So this is the concept. So now we will look for our statement. Our statement is cycloid we have to draw for a diameter 35 mm and rolling along a straight line. So how to draw this? So always remember our diameter of circle and that rolling straight line must be perpendicular to each other. So I will draw diameter of circle from this point. Suppose this is 35, so 10, 20, 30, 35 is here. So this will be a diameter. and this will be a straight line. So diameter, straight line. Now when this circle is roll complete one revolution, so how much distance it will cover? Exactly as per the circumferential distance, and its circumferential distance pi d or 2 pi r. So pi d, so it is 109.9. So path, straight path should be 109.9. Suppose I am counting from this 3 point: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 105, 106, 7, 8, 9. 109.9, that means I can take approximately 110, because exact 109.9 is not possible to mark, so I am taking 110. So you can start counting from any point. Suppose I am starting exactly from 0, then it is 100, 110, this one. So this is a circumferential distance pi d. So I am marking here, this is pi d distance. So pi d, that is 109.9. Remember, even though we are taking 109.9 equivalent to 110, but at the time of writing we must write 109.9, whatever be the exact answer. Now this is our diameter, this is the path. So we will find out the center of diameter. 35 center will be 17 and half. So 10, 15, 16, 17 and half. This will be the center. Now we have to draw a circle. So sharp edge on the center and pencil edge on the bottom end or top end, and draw one circle. So this is a circle which is going to roll on this path, correct? But how we come to know how much division it rolls? So for that we have to divide this circle into equal 8 divisions. Already this drafter is in lock position, so this is diameter line, so second edge will be exact horizontal. So I am just putting at the center and drawing a horizontal line. So this become 4 divisions. Normally we have to divide any circle in minimum requirement is 8 division. So here I am taking angle measuring instrument, measuring 45 degree. So 10, 20, 30, 40, 45. This is the 45 point. Now with the help of drafter I am just measure 145 degree angle, unlock the drafter, matching center and that 45 degree point, and locked it. So drawing this line segment, it will divide this circle in 6. Now using the second side, I can draw a line 45 degree on left side also. So by measuring only one angle, I can divide this circle in equal 8 parts. Now the most important part is numbering. How to give the numbers? So the circle initially touching on this point, when it start rolling, so it will, so numbering, when we giving a number, so it should be in a particular fashion only. Now suppose this is a straight line and this circle is rolling on this straight line, so the division which is come first and touching the road, that will be our number 1. So if it roll along this line, so this point will first touch to road, so this is our first point 1. Then after this point will touch the road, so this is 2, 3, 4, 5, 6, 7, and last again 8. This is our center C, correct? And initially P point is at the contact of line and circle, so initially P is here. So first of all, we will find out the different centers. When it is roll one division, center will be from this line, it will be exactly at the same radial distance. But the position wise, initially C is here, center. When it roll through one division, C will be shifted little bit ahead. So we are going to find out the different center position when it roll through 8 different divisions. So different 8 center will be there. So first we are going to draw center line. This is center line. Now when it roll through one division, that means this one point will touch here. That time center will shift it to this side. So accordingly we must know how much straight distance it will cover when it travel through one curvical division. So when circle roll through this one curvical division, so how much straight portion it will cover. So we have to divide this circumferential straight distance in equal 8 divisions again. Circumference circular distance divided in 8, so circumference straight distance will also divided in 8. So we will use inclined line method. So suppose I am starting inclined line from this P point and I have to divide this straight line in equal 8 division. So on inclined line I am marking 8 divisions: 1, 2, 3, 4, 5, 6, 7, 8. So this is total 8 division: 1, 2, 3, 4, 5, 6, 7, 8. Now last division I have to join with the last end of that circumferential distance. So I am matching this last end to the circumferential end and lock the drafter. When I draw this line, so this circumferential end and this 8 division is joined. Now in the same locking position I have to draw this parallel line from each division, this all these each division. So I am drawing parallel line, then next parallel line, third, then 4, 5, 6, and this is. So if I draw exact parallel line, so my original line, this will also divided into equal 8 divisions. So on this circumference also I will mark a number. So where this rolling circle first going to touch this point, so this is 1, then 2, then 3, 4, 5, 6, 7 and last 8. So when it roll 8 divisions, so ultimately it will cover 8 circumferential divisions on straight line. Now when it roll one division, so this one point will align with this one point, that means one will match, so center will shift it to this side. So how to find that center? So I am matching this horizontal line, center line, lock the drafter. Now when this one match, so I have to draw vertical line up to center. So this will be C1, center 1 position. When it rolls through 2 divisions, so 2 will match. So center will be at a perpendicular position to this C2. So likewise I will draw a perpendicular on center line and it gives respective centers position: C3, then C4, then C5, then C6, then C7 and ultimately C8. So center, final center will be here. So initially center is here. When it rolls, so center position linearly going to change, but height wise it remains same. Now I have to draw all the division lines. For 8 already there is a line, that road line. 1 and 7 there will be a one common line. 6 and 2 already there is one line which is coincide with center line. 5 and 3 common line, and last 4. So I am projecting all these divisions along with the path. Now the next most important work is, when we are rolling this, we have to locate the P position. No doubt one division rolls, that means this one point will coincide with this one point and P will little bit lifted. How to mark? So initially center to P distance is this one. So whenever this circle will roll, center to P distance remain same. Only the position of P will be lifted. So when it rolls through one division, center will be C1. So same distance, C to P distance in a compass. Now when it roll one division, center will be at C1. So sharp end is at C1, and I have to mark arc on one line. So for one there is this line, and this one line can be cut on left side as well as the right side. So there is two possibility, either this is P1 or this is P1. So when it rolls, so just imagine it is going to roll like this. So P point will be lifted like this only. Circle will roll like this and P will move in opposite direction. It is not possible. So it rolls like this. So P will be one division of it, this one. So this is our P1. So this is a wrong point. Now the same distance center to P, when it roll through two divisions, then center will be C2, and I have to cut two line. So 6 and 2 same common line, but remember P1 is here, then after P2 will be here, because it is not going to directly change the position here, because it is slowly division by division rolling. So it is rolling like this. So P2 is this one. Then C3, so center is C3. 3 and 5 common line. For this also it will cut on this side as well as this side, but definitely it is on this one is the correct. So P1, P2, P3, P4, like that. So when it is a C4, so it will cut C4, exact tangential arc. So this will be C4. So P4. Else you can do one thing, you can extend this center line C4 and exactly matching to P4. Now once P position is here at 4 division rotation, hereafter when it rolls through 5th division, so P point will now slightly move down. So it is slightly up one by one layer, and now it reached to topmost. Hereafter when circle rolls, it will move down one by one layer. So P4 is here, then P5 will be about this second line, P6 next to this, P7 next to this, likewise. So center will be the same, center to P distance will be the same. Now for C5, center will be C5, and I have to mark arc on this 5 line. 5 and 3 common line. It will cut on this side as well as this side. Which one is more appropriate? So after P4 definitely it will roll to this side only, so this will be correct P5, because it is rolling ahead and P point moving back, it is not possible. So this is wrong point. So P5 is here. Likewise, now P6. So C6 is the center. 6 line is this one. So I will cut here. So after 5, this will be P6. P7 next. This will be P7. And when it reach to P8, so center is C8 and it will mark here, and ultimately P point again touching the road, that is P8 final position. So excess line, whatever be the excess line I have drawn, I have to erase. So up to this we got the initial P point here, P1, P2, P3, P4, P5, P6, P7, P8. Remember, when circle rolls division by division, move ahead, so P point will be shifted layer by layer. So initially here, then next layer, then next layer, next extreme top. Then it will lower again layer by layer, extreme top to next bottom, next bottom, next bottom, next bottom. Distance of center to P remain always same. So we took the same distance, only the center is changing, and taking a sharp edge on respective center, we are cutting the respective projection line, just taking a precaution that the flow of movement should be smooth. Now we got the all P points. Now we have to draw a smooth curve, so for that we will remove the page. Now initial P is here, P1. So in a construction, P2, then P3. Always draw in a construction, so that if we found something wrong, we can erase and correct it. So P1, P2, P3, P4. Now just tilting the page so that I get a correct hand movement. P5, P6, P7, and last P8. So if I found something odd, then I can erase it. Suppose I think this is not the appropriate curve, smooth. So I erase that portion and redraw again. Now suppose this is my final answer. Okay, it is look good. Then I will dark this. So now applying little bit more pressure and drawing this curve. Now this is your final answer, so it must be little bit dark as compared to other construction. So this curve is known as cycloid. So hopefully you understand the concept. Cycloid, layer by layer point reaching to maximum, and layer by layer it is moving down and reach to again bottom most.